welcome to this new series of videos, which continues the precedent series of videos I've made using chain code material, the chain code learning material in particular. So in this episode, I will start my exploration of Segwit. Segwit. Let me check how it has to be read. Let me consult this LLM talking about BTC, in particular Segwit. How should I read Segwit? What is the right pronunciation? Segwit, segment witness, Segwit, segregated witness. Segregated witness, therefore it's Segwit. In phonetical alphabet, Segwit. Okay, so it's just Segwit. Now, where I'm getting the material to study Segwit, it's from here in learning at chain code. There are these resources, and in particular the self-paced seminars will basically be available for you in this format. So while you maybe are waiting for places in their physical live seminars, you can still study with this self-paced path, which are available online on their website. And I already completed this one, the Bitcoin protocol development first module, which is called Welcome to the Bitcoin Protocol Development Seminar. So all of these links will bring you to a document or an article, and starting from here you will be able to learn more about the philosophy and the history of the protocol in general. Then there are these questions which may help you in delving into this topic. So I already dedicated 9 videos to the first document, which is the Bitcoin white paper. I dedicated many videos to it because I wanted to analyze each chapter one by one. And this is something I would like to repeat in the future, so I can confront my reaction and understanding of these chapters, these words, which I really appreciated going through. So okay, the first one is the Bitcoin white paper. Then we have the white paper errata, which is here in GitHub, available for everybody. So there are some notes for some parts of the white paper, maybe in some cases some updates or some clarification on things that have been left undefined or not really well discussed. And someone is also adding their interpretation maybe. Okay, so for example, there's the last comment, which is happened 2 days ago, and there are some comments from 2017. So it's a project which already has a long history of ratifications. So then we have the incomplete history of Bitcoin development, which is basically made by B10C or B10C. I'm not sure. He's a Bitcoin developer who is well known, I think. I mean, I've seen his name in many places. So he basically is commenting this timeline, which I'm not sure if, yeah, it's himself. He did this timeline in 2019, and then the same year he did like verbalization of the same timeline, which is in the same article actually. So as you can see, there are events until 2020, and it's really well done. I mean, there are links for each event he is reporting here, and as he precise from the title, it's an incomplete history. I mean, it's his work of reconstructing the history of this protocol. Then, so okay, I will go through all of this material personally. I don't think I will dedicate videos for now to this type of content until maybe I have like a deeper comprehension or just knowledge. Maybe there isn't a lot to comprehend other than reading and knowing what happened. Then we have this other article, Bitcoin's academic pedigree. So the concept of cryptocurrencies is built from forgotten ideas in research literature. So this is a really interesting analysis actually about the prehistory of Bitcoin, basically academic prehistory, and what are basically I'm seeing here some of the things that are cited in the notes of the white paper itself, and my commentary had a similar approach to this article. So I commented the white paper as an emerging conclusion deriving from a lot of the research and effort put in this sector by many people. So among many names, there's David Chaum, and Satoshi was part of this movement of people which since the 80s was creating new concepts, new ideas. They were experimenting, they were creating these papers where at the end of the paper they were resolving one problem, but then new problems were opening and they were challenging the reader to resolve those problems. So it was a really dynamic community, and in this article we have the possibility to see some chapters about some technologies that in the end have been the enablers for the white paper and the Bitcoin protocol. So yeah, there are a lot of pieces of the puzzle which are being analyzed here. Wow, really interesting actually. I didn't have a look at this article before now, but yeah, I'm sure I will have some pleasure reading it. And with this, then we can continue to an article which is available on LinkedIn for platform for which I don't have access. It's a closed article. I had the possibility to read this article in another place. It's just this guy, Ray Dillinger, saying something, that he was in this movement at the beginning, and he could not imagine how important it will become. I'm not sure that it's why they put it here and why it's so relevant. I mean, there are a lot of people that can say the same thing. It's kind of obvious that many years ago it wasn't so clear what it will become, and nobody could predict it. Yeah, I don't know. I didn't really appreciate this article here, sincerely. And Bitcoin security model, a deep dive. Should be this one, right? Oh no, it's this one. Okay, so it's an article published in CoinDesk by Jameson Loop, a really well-known name and an active developer. This article has been published in 2016, but then updated until 2022. Consensus mechanism, a lot of banners. Yeah, I'm not using an ad blocker on this web browser. However, there's a lot of discussion about how the security is emerging in the context of this protocol. I already had a skimming and scanning of this article, and yeah, I remember it is quite interesting. It has some really interesting considerations, which can be interesting for both who is starting today their experience, but also for who maybe it's already in the environment since a lot of time, and you know, they just want to solidify some ideas. Okay, then we have the onion model of blockchain security. So this is an article since published in 2020. And it's an interpretation of yeah, the phenomena emerging from the Bitcoin architecture. Okay. Then we have security models with John Newberry. Transcripts. So it's an article published in 2019. This guy was a Chain Code Lab resident. Okay. So it's an interview about nodes. Yeah, looks like there are a lot of it's a discussion about nodes, type of nodes. Then we have the last document here, which is called Scaling Bitcoin. A trip to the moon requires a rocket with multiple stages. It's a long article. I think this is Maxwell's Reddit username, right? Yeah, if I'm not wrong, this guy is what's his name? BTC Maxwell is only one person. What the fuck? Greg Maxwell. think it's himself. Yeah, Gregory Maxwell is null C. Abandon Reddit. What the fuck? Wow, wow, fuck. Fuck that shit. So, okay. He writes here, a trip to the moon requires a rocket with multiple stages, or otherwise the rocket equation will eat your lunch. Packing everyone in clown car style into a trip budget and hoping for success is right out. Okay, quite direct phrasing. Interesting. And there are, let's see if there are controversial answers. You will never learn, will you? Wow. So this looks like quite interesting conversation. But today I don't want to deepen it. Maybe I will keep it for another video. So it was just important to me to to show you where I'm getting the material I'm studying, which is available for everybody. So this first module is, let's say, more historical, cultural. It's giving the frame, especially for the past events, and from here it's easier to understand things like Segwit. So one curious thing is, well, we can see it for sure. There's a good description here, and the rest of this section of this module dedicated to Segwit. Okay, so there we have 3, 6, 9, 12, 13 13 articles, and then we have practical exercises. So yeah, I will start immediately. Let's go. So I will open all of them. I will have a look at what they are. It looks like we are going like at a more technical level with this module. And let's see. So the first one is an article in Bitcoin Magazine, published in 2020. It doesn't say the author. Strange. Okay, we do not have an author here. Then we have the Bitcoin book. Okay. Then we have this article 2017 by Eklitsk. Then we have another article, more recent, 2022. Then we have FIAR, which published this other article. Then we have transcripts. Okay, here we have some slides. So it's a conversation where we have Peter Wool, James O'Byrne, another conversation in transcripts about advanced Segwit. Wow, this is a really nice project actually. If I understood it, it's Bitcoin unlocks the wisdom, knowledge, and history from Bitcoin Tech podcast presentation. We make technical Bitcoin knowledge more accessible to learners, builders, and educators. this project. High quality projects, I will put it in my BTC culture bookmarks folder. Then we have from bitcoincore.org an article, or I don't know how to call it. It's an article from 2016. It's in the URL itself, you can see it. And okay, there's technical explanation mentioning PRs and maybe other places where these feature has been discussed before being implemented. Then we have a mail from the newsletter, the Bitcoin Dev list. This is a bit so I don't think it's necessary, but I remember it. It's Bitcoin Dev. It's a list, mailing list to which contributors can write their ideas to present something. So a month ago I was explaining the attack on Bitcoin Hashcash, which is exploited by ASIC Boost, blah blah blah. This made by Gregory Maxwell. So these people then reply to him, and we can see Peter Todd, Luke Dash Jr., Brian Bishop. There are a lot of incredible names here. Okay, then we have a Bitcoin magazine article which is not available anymore. It's Long Road Segwit, how Bitcoin biggest protocol upgrade become reality. Let's see if we can find it. Segwit Long Road. Search. I will be curious to understand why it's not available. I think it changed it. Maybe it changed the URL, or maybe it was written badly in here. So it's an article by Aaron van Wirdum, which is another well-known name in this space. And this article is post-activation. And yeah, it's a commentary about how such a big change has been obtained. Okay, costs and risks, and here we have wallet development guide. Okay, so this is a guide for those developers who wants to use Segwit in their projects. Then another transcript, in this case again from Peter Wool. New address type for Segwit address. Okay, so now I think we have to wait. What happened? My browser was crashing. So let's go, let's start. What is Segwit? I will go fastly through all these articles. I will not study, let's say, I will try to go and explore all the articles with the goal to have in mind where to look for information when I need it. So I will try to keep in mind, to recollect and keep in mind where the key ideas are presented, and I hope to be able to retrieve them when I need in the future. So let's go. Segwit is short for segregated witness. It was perhaps the biggest Bitcoin protocol upgrade to date, which wrapped several improvements and fixes into one. First of all, let's see how can we remember about segregated witness. Let's see if there are some images which explain to us. Look here, the king.
Okay, a lot of people are asking about segregated witness. Segregated witness is a change in the architecture of transactions that allows the signatures to be in a separate attached data structure and not be computed as part of the transaction hash or transaction ID. Segregated witness has a number of advantages over the traditional transaction architecture, but most importantly, it's an opt-in choice, meaning that you can use segregated witness if you want, and you don't have to use segregated witness if you don't want to use segregated witness. With segregated witness, signatures are placed in a separate tree in the block, and those signatures are called witnesses, and the tree is called the witness Merkle tree. Now, what that means is that the transaction IDs are no longer affected by the signatures, and this fixes a very big problem in the original implementation of Bitcoin called transaction malleability, which allowed people to mess around with signatures and cause transactions to change their transaction ID. This is really an important problem to solve because it affects the ability to implement various types of smart contracts, including payment channels and interesting things like that. Now, segregated witness addresses are different than traditional Bitcoin addresses. There are two different formats for segregated witness addresses. One is segregated witness wrapped inside of pay to script hash or P2SH. Those begins with a 3. And they look very much like multi-sig addresses. So segregated witness, when wrapped in P2SH, which is backwards compatible and easy to use for any wallet, whether it understands Segwit or not, begin with a 3, and they look like traditional Bitcoin addresses. There is also a new format for addresses defined in BIP 176, which is called Batch32. This format starts with the letters BC1, and lots of lowercase.
Okay, for now I will close this as I want to concentrate my attention on this article. So I understand it is a change in the transaction architecture, in the transaction data structure. So Segwit is short for segregated witness. It was perhaps the biggest Bitcoin protocol upgrade to date, which wrapped several improvements and fixes into one. What are the benefits of Segwit? As probably its most notable fix, Segwit got rid of transaction malleability. Before Segwit, an oddity about Bitcoin's cryptographic signatures made it such that transaction could be tweaked to look different, even by people who hadn't themselves created the transaction. While this would make the transaction invalid or change what it did, it will still send the same amount of coins from the same address to the same address. It severely complicated the deployment of layer 2 protocols like the Lightning Network. Okay, therefore, Segwit solved this problem by moving the witness data of a transaction, which includes the signature, to a new part of a Bitcoin block. As such, it paved the way for the Lightning Network and other layer 2 protocols. As an added bonus, Segwit also offered a modest block size limit increase to a theoretical 4 megabytes, or a more realistic 2 megabyte limit, depending on the types of transaction included in blocks. To be exact, the block size limit was replaced with a 4 million weight unit limit, which introduced a new way to count transaction data. This means that users with Segwit options wallets pay lower transaction fees. Plus, through a technical trick called script versions, Segwit also made it easier to deploy further upgrades to the Bitcoin protocol. One of these upcoming upgrades could be Schnorr signatures, a new signature algorithm that would further increase the programmability and flexibility of the Bitcoin protocol. Last but not least, all of this was made possible without requiring a backward incompatible hard fork protocol upgrade. So this was a soft fork, which this type of upgrades require support from only a majority of hash power to avoid a split of the network, while hard forks require network-wide consensus. Who developed Segwit? A version of Segwit was first developed by Blockstream for the Blockstream Elements sidechain project. After Bitcoin Core contributor Luke Jr. figured out how Segwit could be deployed on the main Bitcoin protocol through a backward compatible soft fork upgrade, it was developed by the Bitcoin Core development team. Specifically, the relevant Bitcoin improvement proposal was authored by Eric Lombroso, Johnson Lowe, and Peter Will, who also did most of the coding. The rest of the team helped throughout the process in various ways, including review and testing. The pseudonymous Litecoin developer Shaolim Fry and Bitmain warranty engineer James Hilliard are credited with developing alternative activation solutions for the soft fork. Okay, interesting. Was Segwit controversial? So with Bitcoin's technical community, Segwit was not controversial. Outside of Bitcoin's technical community, however, some preferred a different scaling solution for Bitcoin or did not believe Segwit itself was sufficient as a scaling solution. This had the effect of turning the Segwit proposal into something of a bargaining chip in a much wider dispute full of controversy. Others tried to discredit Segwit altogether. The only point of controversy that arguably had some validity to it is that it would have been cleaner, code-wise, to deploy the upgrade as a hard fork instead of a soft fork, as this would leave less technical doubt in the protocol. Deploying Segwit as a hard fork would have had its own problems, however, which most developers and proponents of Segwit believed would have been much greater. Some of the other controversies surrounding Segwit. Some, for example, claimed it will allow miners to steal funds are simply hogwash. Case point, Segwit has been live for years and no miners have been able to steal any coins. How and when did Segwit activate? Segwit activated in August 2017. How activated is a long story. While it was first publicly proposed and included in the Bitcoin Core roadmap in December 2015, and the code was ready less than a year later, it took until the summer of 2017 for the protocol upgrade to go live. This in large part because some significant Bitcoin miners refused to activate the protocol upgrade. As originally designed, Segwit would go live on the network if a supermajority of miners signaled support in the blocks they mined. The motivations of these miners are still speculated about, but it seems that they either used Segwit as a bargaining chip or they blocked the upgrade because it was incompatible with a mining optimization called ASIC Boost that they were secretly using, or both. Either way, by 2017, a grassroots movement of Bitcoin users relied around an idea first proposed by pseudonymous Litecoin developer Sean Limefree, called a user-activated soft fork (WASF). These users announced they would activate the upgrade on their own Bitcoin nodes by summer, regardless of what the miners will do. If these users would have gone through with their original plan, it could have split the Bitcoin network into a version with the Segwit and a version without. Mere days before the UASF deadline, miners activated Segwit after all. Technically speaking, they did this through yet another activation mechanism proposed by Bitmain warranty engineer James Hilliard. Wow. So how do you use Segwit? You use Segwit by using a wallet that has integrated Segwit. This wallet should generate Segwit addresses for you, and when you make a payment from such an address, the fee you will need to pay will be lower, and if you haven't used Segwit. There are two types of Segwit addresses. One type, P2SH, starts with a 3, though not all addresses that start with a 3 are Segwit addresses. The other, batch 32, starts with BC1 and is always a Segwit address. P2SH Segwit addresses are actually a bit of a workaround. While Segwit transactions from such addresses are cheaper than non-Segwit transactions, transactions from batch 32 addresses are the cheapest. Addresses that start with a 1 are never Segwit addresses. Some wallets that have integrated Segwit include Bitcoin Core, Electrum Green, Trezor Ledger, and a number of others. Why doesn't everyone use Segwit? Well, over the 2 years after Segwit activated, less than half of all transactions on the Bitcoin network utilize Segwit. From an individual perspective, there are probably 2 reasons not to use Segwit. The first reason is that implementing Segwit requires an upgrade, and some people are simply slow to do that. For large companies, it may require significant time and effort as a whole system may need to migrate. Similarly, some wallets and other applications just haven't integrated Segwit yet, presumably because they have other priorities. The second reason will be political. Some people suspect that certain companies aren't upgrading to Segwit as a sort of protest. They would have preferred different scaling solution or more scaling solution. They may even be trying to drive up transaction fees on Bitcoin in order to incentivize users to migrate to altcoins. It's worth noting that even if everyone doesn't upgrade to Segwit, those who do upgrade enjoy the benefits regardless. While the overall fee level might be slightly lower for Segwit users, if everyone else were to use Segwit as well, the added benefit of complete migration is small. Plus, if fewer people use Segwit, Bitcoin blocks are smaller, which has benefits as well. Okay, so it gave us an idea of how it has been deployed in which context. Now, segregated witness. So this is from, I think, from the Mastering Bitcoin book. Yeah, right? Mastering Bitcoin, and also there's a video by Jimmy Song.
Alright, so let's talk about Segwit and pay to witness pub key hash. Alright, so let's talk about what segregated witness is. What is it? It's a way to fix transaction malleability, number one. That's why it's important for the Lightning Network. It's a way to reduce network transmission because you don't have to get that witness data if you don't want to. It's a way to increase transaction throughput because it's a block size increase. And it's also a way to allow for smoother feature upgrades. The gist of it is that this is the transaction that you saw before, and this is sort of the replacement. Like you transmit the thing on the right. You'll notice that the script sig is always the biggest element of any transaction. What we're doing is reducing that to very little, and that's the general idea of it. Now, there are some caveats to that, which I'll get into. But let's talk about pay-to-witness pub key hash. This is what you would call native Segwit. You probably haven't seen that many transactions that utilize native Segwit because those addresses start with BC1. Okay? The ones that start with a 3 are a different kind of Segwit. They're what I call nested Segwit, and we'll get to that after we learn about pay-to-witness pub key hash. All right. So what is it? It acts exactly like pay-to-pub key hash, but segregates the script sig data. So it puts it somewhere else. Okay? This is an attempt to sort of, yeah, we'll see. Just give me a minute. It's a new type of script. So pay-to-pub key hash is one type of script. Pay-to-script hash is another type of script. Pay-to-pub key, bare multi-sig, they're all types of scripts. This one is a different one. It's pay-to-witness pub key hash. And the key to making this a soft fork is that different data is sent to old nodes versus new nodes. Pre-Segwit nodes get one type of data. Post-Segwit nodes get another type of data. And here's how that works. Here's what the old nodes get. And this is basically what it looks like. Instead of that whole huge script sig field, they get nothing in the script sig field. Okay? Instead, they just get everything else looks exactly the same, but script sig is empty. That's the real difference here. Upgraded nodes get something else. Okay? They are actually doing the signature verification. So you'll see that a lot of the fields look the same except for 3 things. So first of all, right after version is a Segwit marker, 0, 0. Right after that is a Segwit flag, 0, 1. And the reason why it's done that way and why you guys were getting errors earlier about the amount being like the fee being gigantic or something like that is because we were getting the segregated witness serialization for the previous transaction. So when it was looking for the output for the previous transaction, it would get the serialization. And whenever you parse a segregated witness serialization with like a normal
I'm stopping it because I like the content and I would like to spend like more time on it, in the sense that I would like to go through this content by Jimmy Song, Calmer. In this moment I just want to skim and scan all the content we have in this module by chain code. And as I spent a lot of time on this really basic article first, I just want to now skim all the rest. So here we have the Mastering Bitcoin chapter about segregated witness, and this book was first written and published by Andreas Antonopoulos himself, I think. The first edition was written only by him, and then he published it as a GitHub project, so everybody can contribute and change it in some way, add comments to change it. So we have a segregated witness chapter. Actually, I think that one of the best things I can do is also reading the entire book, which talks about transactions, network, and wallets, and of course it talks about segregated witness. So there are 1, 2, 3, 4, 5, 6, 7 paragraphs. Okay, as early as 2011, protocol developers knew how to solve the problems of circle dependence, third-party malleability, and second-party malleability. The idea was to avoid including the input script in the calculation that produces a transaction TXID. Recall that an abstract name for the data held by an input script is a witness. The idea of separating the rest of the data in a transaction from its witness for the purpose of generating a transaction ID is called segregated witness. The obvious method for implementing Segwit requires a change to Bitcoin's consensus rules that would not be compatible with older full nodes, also called a hard fork. Hard forks come with a lot of challenges, as we'll discuss further in hard forks. Yeah, there's a chapter about it. An alternative approach to Segwit was described in late 2015. This would use a backward compatible change to the consensus rules, called a soft fork. Backward compatible means that full nodes implementing the change must not accept any block that full nodes without the change would consider invalid. As long as they obey that rule, newer full nodes can reject blocks that older full nodes would accept, giving them the ability to enforce the new consensus rule, but only if the newer full nodes represent the economic consensus among Bitcoin users. We'll explore the details of upgrading Bitcoin consensus rules in the chapter dedicated to mining. The soft fork Segwit approach is based on anyone can spend output scripts. a script that starts with any of the numbers 0 to 16 and followed by 2 to 40 bytes of data is defined as a Segwit output script template. So here this statement is referred to what Jimmy Song was showing in that video, I think. The number indicates its version. The data is called a witness program. It's also possible to wrap the Segwit template in a P2SH commitment. Sorry, I have to open the door to my friend here. Okay, from the perspective of all nodes, these output script templates can be spanned. Can be spanned with an empty input script. From the perspective of a new node that is aware of the new Segwit rules, any payment to a Segwit output script template must only be spent with an empty input script. Notice the difference here. Old nodes allow an empty input script. New nodes require an empty input script. An empty input script keeps witnesses from affecting the TXID, eliminating circular dependencies, third-party transaction malleability, and second-party transaction malleability. But with no ability to put the data in an input script, users of Segwit output script templates need a new field. That field is called the witness structure. The introduction of witness programs and the witness structure complicates Bitcoin, but it follows an existing trend of increasing abstraction. So here the author says to recall from another chapter that the original Bitcoin white paper describes a system where Bitcoins were received through public keys and spent with signatures. The public key defined who was authorized to spend the Bitcoins, whoever controlled the corresponding private key, and the signature provided the authentication that the spending transaction came from someone who controlled the private key. To make that system more flexible, the initial release of Bitcoin introduced scripts that allow Bitcoins to be received to output scripts and spent with input scripts. Later experience with contract protocols inspired allowing Bitcoins to be received to witness programs and spent with witness structure. The terms and fields used in different versions of Bitcoins are shown in this other chapter. Okay, so sincerely, I'm not really secure. I think there is the necessity to do some practical exercises on this topic, so I'm happy that they are available here, and I hope to have time to practice them a bit, as I feel this is a really practical topic, like constructing transactions, different techniques and templates to do it. I don't think it's really that it really makes sense to only talk about it. I think that it's easier and faster to comprehend these things, like really writing down transactions and watching the visual differences. So there's a lot of really fascinating technology in Bitcoin. Even more fascinating to me is the history of different flows in Bitcoin and how they've been addressed. In this post, I want to explain one of the most subtle and nefarious Bitcoin flows of all time, transaction malleability. So this is in a post by I don't know who. Even Klitze. Wow, nice. I like this minimal structure of his homepage. He has a lot of interesting content. Wow. Nice. Okay, so in this post, he does an overview of the malleability-based attack, transaction malleability significance, and how transaction malleability actually works, and then the future, which I imagine includes some consideration about Segwit. Segwit. Okay, so I will not go deep in this now. I feel like I would prefer to have a look at some of those exercises. Maybe not this necessarily, but I really want to build some visual schemes, and then I feel like I will be in a better position to read all of this. Just another quick pause. Okay, so I'm back. Nice. Okay, therefore, as I was saying, I will not go deep into this article. I don't feel like I'm ready to comprehend it all. This data is bundled to blah blah blah. Alright, material to how Bitcoin. Bitcoin is a peer-to-peer operating on a gossip. Here's transaction attack works. Blah blah blah. instance, suppose. Okay. 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 So what I understand is that I need to study transaction structures, script and transaction structures, and the actual messages that are sent over the network. And this is something I've noted also in my other series of videos about covenants and operational codes. So this common issue I found, I think, will be addressed in a series of videos dedicated to transaction structure, script and operational codes, messages, and the way everything is encrypted, codified, and transmitted over network. Which means again that I'm thinking about reading again Mastering Bitcoin, which is basically a really good book about these topics. Also, Jimmy Song's book Coding Bitcoin, Programming Bitcoin, I think is about the same topics. However, I never read it all. I read only the first two chapters, which talk more about elliptic curves mathematics. But yeah, I'm feeling it's the right moment to read again these books. Okay, so here we are having the same type of discussion, which I feel that I can appreciate again with refreshing my understanding of these topics. Okay, yeah, I'm not discussing it as I'm not really reading it. So here are some quality conversation, which again I would love to fully understand. So I need the vocabulary, I need the ideas to be solid in my head, and I will go through them again. So this is basically a video where I'm discovering unveiling my ignorance at full and yeah, just convincing myself that I need to dedicate time to read those books. Nice, okay, so this is fully inaccessible to me currently. I need some days to be able to appreciate this text. Okay, the long road to Segwit. So this is a historical article. So I will be able also to understand, but to better understand the facts that are mentioned here. Here there is only some history about how the discussion has evolved, and there's a wider contextualization, mentioning also the block wars. And here there are some post implementation guidance tips which are offered on the bitcoincore.org website, and here another transcript. Okay, so nice. At this point I will just close this video and go immediately to procure myself a copy of those books which I mentioned, Mastering Bitcoin and maybe Programming Bitcoin. I will go through them, study, repeat. Maybe from those books I will also expand the map of my ignorance, so I will discover new things which I need to study. That could be broader technical, computer science technical topics. I remember there's a lot of codification that was never really clear to me. I never mastered those topics, so for sure I will have a lot to study. Maybe the next video will be published in more than a week instead of my weekly publishing frequency. Therefore, thank you for being here. I hope unveiling my ignorance helped you this time, and well, see you in the next video where I will be more prepared. See you next time.